You definitely, you cannot write this immediately. You cannot say, oh, because it's always positive, 1 over x squared minus 3 greater or equal to minus 1. Or whatever that you do lah. You don't write this immediately. Actually, the first thing that you try and do is here. This is negative 1. The right hand side must always be 0. So the first thing you try and do, oh, okay, let's do the first few steps very, very quickly. The first line I think is like that. At least we must bring plus 1 on both sides and then combine the fraction. Alright, combine the fraction. And then you will get this. Just very quickly you get this. Sorry, the problem wasn't this one. The problem is actually this numerator. Right? This one still cannot solve. Still cannot factorize. Follow? You do the same thing, apply quadratic formula. Your b squared minus 4ac, just a quick calculation. Your b squared minus 4ac is obviously negative. Okay, now. How do we show that this is always positive? Discriminant, very good. So what most of us will say is, oh, okay, you calculate discriminant, negative, then it's always positive. Wrong. Yes, you must have two conditions. One, discriminant is negative. Two, you must mention that the coefficient of x squared is positive. With these two conditions, only then you can say with confidence that expression is always positive. Alternatively, you could have completed the square. There are two ways to do it. In order to show that it is always positive, you can say complete the square, which I'm going to show, or you find discriminant, show that it's negative, plus the fact that the coefficient of square is positive. So I'm going to show the complete square. Some of us may not like complete square. Alright, this is the completed square form. It's quite obvious now. Once you can write this in completed square form, you can say for sure, this thing is always positive. But you must also mention. You must also say that since this line is crucial, you must say that this is positive for all real values, right? Then what you do is you actually test one for only these two critical values. Follow? You only test one for these two critical values, which is plus 3 minus 3. Alright? Sorry, this thing should be a hollow circle. Must be this thing, sorry, not this one should be hollow circle. Not solid. It cannot. It should be hollow because it's in the denominator. Follow? Because it's the denominator. X cannot be root 3, and x cannot be minus 3. So it must be hollow circle. Make sure you get that. Even though this is greater than the full square. Any questions? All okay? So essentially you're solving this 1 over this is positive. Because this is always positive because of x. Follow? Done. So therefore, the solution is this. I think I leave you all to answer the questions, this question for yourself. Why can we not cross multiply? What we mean by cross multiply is here, right? This one cross multiply like that. This one multiplied by minus 1. Okay. Can we cross multiply? Why not? Because you do not know whether x squared minus 3 is positive or negative. Okay? If it's negative, you have to change sign. If it's positive, then you don't change sign. That's the problem, because x is unknown. Okay? Good? Follow? Okay? Good. Okay, let's move on. Okay, now we introduce this thing called the absolute value function. Some of us already know, so first time seeing it. Never mind. It's very simple. A very simple idea. It essentially means that I want to find the absolute value, whether it's plus or minus. Absolute value of 2, which we sometimes say mod 2, is just 2. Absolute value of minus 3 is just 3. Absolute value of minus 100 is just 1. Absolute value of minus 5 is just 5. Right? Okay? So, well, this one is easy for all of us. Well, this one is easy for all of us. But I want us to know this definition. And it makes perfect sense. Right? If x is positive, or even 0 doesn't really matter, this equal sign in 0 doesn't really matter. If x is positive, then mod x is negative. But if x is negative, you take the negative of it, you will end up with positive. Essentially, what you are doing is this. So that you can apply it. One more time. Mod. Just now, mod 2, right, is 2 because 2 is positive, it's just 2. It's just negative of negative 3. That's what we're saying. Because ultimately, when we want absolute, it's defined as absolute value of x, it's just you want the distance from 0, that's all. Right, you think about it like that. Right, you look at the number line, essentially what you want the distance from 0. I think of it like that. If this is minus 5, you want this one, it's 1. If this is 4, correct? Follow what I'm saying? Can? Alright. So get the definition clear. Absolute value of x is just the positive value. Can? Okay. Some quick properties. I should think it makes perfect sense. Alright? I don't intend to prove it. You can prove it yourself. Really, it's quite easy. Absolute value A multiplied together. It's just absolute value A times absolute value. Of course. Right? You can prove it yourself. Division also works. I just want to warn all of us. This is fine. This is not true. Correct? This is mod A plus B is not the same as mod A plus mod B. To prove something is a bit more difficult, but to disprove something is easy. Just give yourself a counterexample. How? You just give yourself one positive number, one negative number, you will know that it is positive. Correct? A is 2, B is minus 1, and I think you get an answer. That kind of thing. Okay? Alright? This one, very important. Note here. It's very tempting to say mod x is plus minus x. Because all of us look at the definition and say, oh, it can, because mod x could be minus x, then you can say plus minus x. Actually, it's not correct. It's not correct. Because if I say mod minus 3, is 3. It is not plus minus 3. Right? Yeah. So don't write this kind of thing. Don't write plus minus when you actually mean mod. Plus minus means it actually can take on 2 possible values. Mod means only one value. Can? Okay? Okay, now we tackle the graph. Does this graph make sense to you? Let's go back to the definition of modulus function. Let's look. If I use this definition, if I draw, what we are saying is if x is positive, this is y equals to x, like that. Correct? If x is positive, this one is exactly this one, y. For the negative x portion, For the negative x portion, you get if y equals to negative x. So it's this one. So therefore, to combine y equals to mod x. Sorry, my line not very straight. Okay, to combine, this whole thing is y equals to mod x. You follow what I'm saying? Understand? Okay, any questions? This is the graph. This is the graph of y equals to modulus x. You don't believe, you try. You substitute 2. You get 2, 1, 2. You substitute minus 5. It's the 5. Follow what I'm saying? Make sense? Questions? Alright, okay. So that's that. Okay? Are you able to retrieve the modulus function on your GC? Of course you can. Alright? Yes. The Tuesday one, no lah, I forgot. Today one, yes. Okay? So, what do? Again, I go back. Okay, let's go to y equal. You go to math. Like this one. Math. Go to the right. And the absolute ABS, the first one. 1. There you get an X out. Okay, then you go to graph. Sorry? You don't understand now? Do it on. You turn off first, then you do it on. On. And there is also a shortcut. Alternatively, if you want to retrieve the absolute function, you can press alpha window. Okay? You can press alpha window. This is a shortcut of frequently used functions. Alpha window, you can retrieve your ABS symbol. Okay? These are the frequently used, these are the shortcuts. Alpha window. Can? Alpha window. Then you press 1, you will also get the same thing. Alpha window. Can? Okay, that's that. So you get a graph. So now, how do we solve inequalities involving absolute functions? Alright, how do we solve it? First thing we need to see. Let's say I want to solve mod x smaller than 3. So we draw a line y equals to 3. And then we have our original graph, which is y equals to mod x, like that. If I want this graph to be lower than 3, then actually the solution is here. Only this part from minus 3 to 4 3. Make sense? So therefore the solution is, if I want the green to be above the yellow, then the solution is either x is smaller than minus 3 or x is greater than 3. So what's more, 3, 5, and 10 doesn't really matter the values. So I think we can generalize. To say that to solve x, mod x smaller than k, of course k must be positive, right? Otherwise nothing to solve. Alright? For solve mod x smaller than k, then this is the general, this is the solution. Solve mod x greater than k, this is the general solution. Follow what I'm saying? Understand or not understand? Don't understand? Okay, one more time. Now I'm making use of the graph again. agree that this is the graph of y equal to mod x? Okay? Or this is the y equals x, this is y equals minus x. Let's say I want to solve mod x greater, solve smaller first. Smaller than 4. Graphically, how do we solve? We sketch this and we sketch this and see which one is above, which one is below. So I sketch y equals 4. So how's it good? Okay? Now, in order for mod x to be smaller than 4, it must be this part. It must be here. Because this part is where the graph lies below 4. Right? What is the range of values such that this first graph is below this 4? Yeah, exactly, it's minus 4. Correct? So I generalize and say, what if this is k? So now this is k, this is k. Then what happens? The intersection point between this and this must be k and minus k. Follow what I'm saying? So therefore you generalize and you see this result. Okay? Is that alright? Okay. H2 students usually will use graph to solve inequalities involving absolute function. That's how we teach. But I think as FF students, you must be also quite comfortable with using the algebraic method, which is using this idea of algebraic. So we'll go through some. Alright. Example 8. Okay, this one is a very simple example. So I don't go through the keystrokes. You all can do it all by yourself. I already showed. Alright. How do we do it? You sketch this graph. Sorry. What did I just do? You sketch this one and you sketch 7 as y1, y2. Find the intersection points. You don't know how to find intersection point on GC? Don't know. Okay lah, very quickly lah. Show lah. You all can do lah, otherwise you'll fall asleep, you know. 2x minus 7. Correct? There you have, I put minus 5, sorry. Minus 5. Then this one is 7. So now, you want 2x minus 5 to, mod 2x minus 5 to be greater than 7. Then this one, x is smaller than this because you want blue to be higher than red. X smaller than this value, x greater than this value. What is this value? You don't read off. Don't read just on this minus 1 and this value. Okay, don't read it's not like it can be minus something 1.01, okay? So you use a function called intersect. Second, calculate 5. Don't need to scroll down, just press 5. They'll ask you what is the first curve that you want. Right, first curve. Right? They just anything. First curve means you see y1, they say, oh, y1, okay, enter. Second curve, y2, enter. Guess. Why do you need to guess? You need to be very accurate, but just choose a point that's close to where the point you want to find. Enter. Then they'll find for you. See, the answer is x equals to negative 1. Follow? Let's say you want to find this point. The other point, here. You do the same thing. Can? Okay, second, calculate 5, y1, y2, then you move your cursor to the other side. You're lazy to move, you can enter the point too. Okay, there are 6. Can? Alright, done. So with that, you know this minus 1 and 6. Answer out. Hence the solution is x smaller equals to minus 1 or x greater. This is just what I said. Example 8 can be solved in another way. Okay? If I have this same question, you don't use a graphical method, you use a algebraic method. For such a simple question, I don't like to draw graph, to be very honest with you. Or first, you got to sketch on your GC. Second, you got to sketch it on your paper. Because you cannot sketch on GC without showing it. You can't say by sketching a graph, answer is this. No, you at least have to sketch the graph on your script. So I would think for such a simple question, it's not difficult to solve it algebraically. You just say that using this result, okay? Therefore, you say 2x minus 5 smaller than minus 7, or 2x minus 5 greater than 7. Using this result. Make sense? Make sense? Because just now we showed this one. Correct? Yes? Good. Can we just solve? We have two inequalities to solve, then we are done. This one very quickly you can get an answer. Therefore, x smaller than minus 1 or x greater than 6. Just two lines and we are done. Other than press. Or, of course, there are some inequalities that you have to use graph. Not have to lines, faster to use graph. You decide. In this case, I will not use graph. I will just use illustrate. Okay. Question. An example is this. This one we have a slight problem if you want to use algebraic method. So we will use a graphical method this time. Because this you don't know whether this is possible or not. Right? So we do use a graphical method. You sketch the graph here. I'm not going to go through it with you. Sketch it. You realize that by GC, you realize that this is 0, this is 6. Oh no, sorry, no, it's not 6. This is 6. This is 6. This is 4. I mean, by GC, I'm not going to go through. By GC, sketch. What do you write on your script? You don't just hang the solution, okay? You have to sketch this graph out on the script, okay? You follow what I'm saying? Then by GC, you have to sketch this out, get the shape out, label the intersection point, then say hence the solution is x equal to 0 or x, between 4 and 6. Any questions? All okay? Yes. Can you? Actually, yes, you will still get an answer. But we don't recommend that you do it. Yeah. Because actually it's more complicated. You have to solve quadratic on both sides, two quadratic. You follow what I'm saying? You have to solve two quadratic inequality, then you combine. Actually, it takes more time. You follow what I'm saying? Oh. So I would rather not. Okay, example 10. So we have something like that. Again, we sketch on your GC. You have only one point of intersection here. You have only one point of intersection. You will realize that This point is 3. Right? You have a point 3, 2 here. By GC, the only point of intersection gives x equals to 3. Therefore, the answer is x greater than 3 because you want this graph to be lower, to be below the ring. So therefore, x greater than 3. Again, one more time. This is what you're supposed to get in the GC, okay? On your script, okay? You have to show this. You cannot just write by GC done. Or you have to sketch it. Okay, I will use example 10 to illustrate that you can actually use the alternative, the algebraic method. Why? Look, you can use algebraic method here because of this. You want more x minus 1 to be smaller than this. You can use it because you're quite sure this is possible. Because this is possible, this is bigger than this. So this is surely possible. So therefore, want something smaller than something positive. You can use that general form, that idea. You say that therefore, here, since mod k is smaller than a, and the mod x is smaller than a, and k is for sure positive, I immediately use this. This is fast. Whereas for the above example 9, you have a quadratic, I won't do it. So you must employ the right method. You follow what I'm saying? Alright? So, same example, example 9, we will use the algebraic method. How do we do it? Since we have mod x minus 1 to be smaller than 2x minus 4. Now we use this idea, okay? We use this idea. Correct? Then we have minus 2x plus 4, x minus 1, 2x plus minus 4. Oh, no need. Okay, this one can be used without proof, okay, sorry. This one, I just, no need to copy, no need to reject. You just start with it. Good question, thanks. No need to copy this game. Now look, how do we solve this one straight inequality like that? Technically, actually, if it's made out of two inequalities, this smaller than this, and this smaller than this. So we rewrite it. Okay. We write into two inequalities. So, rewriting, we are actually trying to solve minus 2x plus 4 smaller than x minus 1 minus x minus 1 and 2x plus 4 minus 2x minus 4. Now, you all understand, huh? This. Should this be an and or should this be an or? This is very crucial. Should it be an and or should it be an or? Now we are. Okay, I give you all 10 seconds or 30 seconds to think. Okay, then after that we cast a vote. Okay? Must have a vote on it, Ready? We cast a vote, must have opinion. If it's and, raise our right hand. If it's or, your left hand. Ready? One, no. Ready? One, 2, 3, go. Everybody's end now. not sure. I'm not sure. Somebody say, some say, oh. Okay, why don't those who say N try and convince the people who say, oh? Let's say a number, very good, this is a number. Let's say, for example, you have like that. So you write, is it x greater than 4 and x greater than smaller than 10? Or do you write x greater than 4 or x? Quite obvious, right? Or it must be smaller than 10 and greater than 4. A is the intersection. Right? Yes, it must happen. Oh. Sure. So you must write, you must write. Because if you don't write, if you don't write with a comma, later on you don't know how to combine the two results. Yes. Yeah, so you have two. Yes, so you have two cycles? No, it must be, if this must be this, then you must have two ends. You must have two ends. I give you an example. Use numbers. You say more x smaller than 4. Right? Then x must surely be smaller than 4. X must surely be smaller than 4. But also x must be greater than 4. But what your question is this: you write before x smaller than 4, you can be very sure x must be smaller than 4. And at the same time, x must be greater than 4. So this actually is true. But at the same time, x must be greater than 4. But this is true, there's nothing wrong. I'm going to say that this is true. It must be this in order for this to be satisfied. You follow me? So there are two conditions to be satisfied. This and this. Okay? Yes? Okay. Okay, therefore, you have two inequality, 3x smaller than 5 and x greater than 3. Oh, sorry, greater, sorry, I mean greater. Greater. Oh, this one minus. Right? So we end up with two inequalities here. We need to combine these two. Usually, we will not have an n in our final result because if it's n, it can usually be 5. Now think about it. You have a number, you want the number to be greater than 3, you want the number to n to be greater than 5 or 3. You draw a number line. I think this one is secondary school stuff, you all should know by now. Which one do we take? We take, therefore, x is greater than 3. Done. Or because 5 over 3 is a smaller number. Okay? You draw a number line, you know what I'm talking about. Question? Oh. What time does this lesson end? I don't have notes. I don't have notes of the next chapter. I tell you what I think got time. 11. This you have to call 15 minutes only. You think what? I only have 15 minutes left. I have 2 examples left. Right. Okay. So correct. Just nice. We finished this today. Okay, come. Example 11. Okay, yeah, I'm going to show again 2 methods. I'm going to show 2 methods again. This is inequality. I'm going to show 2 methods. First method, sketch graph. Now when you sketch graph, you you must be very careful. Because when you sketch graph, you may think, okay what, I can sketch this, therefore I label this equal, this one is, I think this is 5, you find somehow this is 5, and that's it, you're quite happy. Correct? You may be quite happy. They say, okay, in order for the blue to be above the red, therefore I take x greater than 5 times. Right? I take x greater. Exactly. You must know whether there's another one here or here. It's here, right? How do you see it? Then how do you find it on your GC? Zoom fit. Wow. Okay, let's do it together. Okay? Hey, you're doing it, you're doing it. Don't let me do it. This is not a show, don't watch show. So, usually we will press Zoom 6. I say again, usually we do 6 is a standard Zoom setting, that is minus 10 to 10, minus 10 to 10. Then you realize you see this, exactly what you see in your notes, you're quite happy. Therefore, this is, if you solve this, 5. You want to see more. In fact, do you want to see more on this side? No. Not really. Right? Actually, if you look at this, not really. So because you can see visually, you know that this is steeper. The rate is steeper, so it's all right. Okay, the rate is steeper on this side. But now, because rate is steeper on this side, you will end up with an intersection. That means you want to see more of here. What I will do is I go to window. I want to see more, the x maximum, maybe I see 20. Okay, I see 20 because I want to adjust it, I want to see more x to 20. Then on the other side, I don't need to see minus 10. Maybe I see negative 5 will do. Okay? Okay? Whether you want to press zoom fit or not, doesn't really matter. You want, you can press zoom fit. What does zoom fit do? Zoom 0. So what does zoom fit do? Zoom fit does this. You specify your x minimum minus 5. You specify your x maximum 20. You don't need to specify your y minimum and maximum. They will adjust it so that you can see the whole graph. That means they help you adjust the y minimum and y maximum so that you can see a nice graph. So clever, right? Then you are quite convinced that there is an intersection point here at 5 and 17. Then you do your normal thing, intersection. Follow what I'm saying? Let me see your notes. So can we then, on your right hand side, okay? Now you have to do some work, okay? Now you have to sketch for me, So this is not what you will sketch. In fact, this is what you're going to sketch. So you're going to sketch it, okay? On your script, I'm going to sketch it now. Let's say I have ruler. I pretend I have ruler, okay? I'm going to do this. I'm going to do this. This, like that. Use your ruler, okay? Use your ruler. And then you will exactly sketch this because this is like that. y equals to 2x minus 2. And then you have another graph. Notice it's just a sketch, you don't need to be super accurate. Y equals to 3x minus 7. Can you sketch please? Sketch, must sketch. I would definitely label, if you, okay, can you tell me, can you tell me, you don't know where is this one? What is the body of this one? You can find or just observe. Quite obvious, right? It's obvious. Because you look there, and a bit more than 2, you get a positive number. A bit less than 2, and then 2 is 0. Look. And x equals to 2, y is 0. Here, 7. You don't need to calculate, you can observe and you see this is 2 and 7. Just for completeness, I will do this. And this one is the most important. Correct? This one you will say that either 5, 6. And this one is 17, 30. Then by GC, you get answer. X is between 5 and 17. Done. Okay, what is an alternative? An alternative is this. If you look at this inequality, you have 2 4x minus 2 and 3x minus 7. Are we very sure that these two sides are non-negative? Non-negative. So if they are both non-negative, I can square both sides. As long as both sides of the inequality are not negative, I can square both sides. Can anyone tell me why I must make sure they are non-negative? If I tell you 4 is greater than 3, I square both sides, 4 squared greater than 3 squared. Sure. If I tell you 3 is greater than minus 4, if I square both sides, I have a few problems. But if you have 3 greater than minus 2, then how? You follow the same? Follow. So, if both sides positive, definitely okay. I can square both sides. It's definitely okay. So, what I'm saying here is, since both sides are positive, I can square both sides. Follow? Follow or don't follow? Okay, so we can square both sides. Now, what do? We can say, okay, 2x minus 2 now, then you struggle and say, how are you going to solve this? I have a 4 and a square. Very good. So I'm going to introduce one result to all of us. Actually, not introduce, actually it's written up there. What is mod a squared? Actually it's the same as a squared. It doesn't matter whether you have the mod or no mod. Make sense? Or you think about it, negative 2 you put in, it's the same as 2 squared. 10 is equal to 10 squared. It works for all numbers, whether positive or negative. So, I think we are good. You can carry on and you can get the answer. Okay, so I'm going to write the next line and then I'm going to put dot, dot, dot. You can do it on your own. So, it's the same as 4x squared minus 16x plus 16 greater than 9x squared minus 126x plus 441. Dot, 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 dot. You will get same answer. Okay? The dot 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 you can either you're fast enough, you now also be also never mind, just put dot 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 back. But the most important result is this. I want to highlight this one. Gain and stress. This only works. This does not work for inequality. Only works when your left hand side and right hand side are both not negative. You're very sure both sides are not negative. Very good question. What if both sides are definitely negative? What if A greater than B and A, B are negative? Right? And A squared. Right? That's right. But you must say it for sure, but you must know. Alright? Okay, 4 minutes to do the last part, last example. Okay, to solve this, I don't think it's a big problem. Correct? You can quickly solve and you realize that I've got a dot dot dot. You will get x is smaller than minus 1 or x greater than 2. I put dot dot dot, okay? You can do it alone, okay? Practice, Okay? Dot dot dot. The first one is pretty standard. Number line, and you just text point, whatever. Hence, I want to go through the next part. Hence, solve this inequality, which is order 4 inequality. Then you say, I don't know how to solve. Alright? And the key word here, exam still up. Hence. That means you cannot, if you want to use GC, also cannot. You must make use of this result to solve that. I say again, the word hence means that must make use of previous part. Essentially, you must make use of this answer. Follows what? We try and link this back to that. How? Look. You, for part 1, x4 minus x square greater than 2. I can rewrite it as x square square minus x square greater than 2. Why do I write it like that? If you look very carefully, I have already solved x squared minus x greater than 2. I have already solved y squared minus y greater than 2. Now I have something squared minus something greater than 2. How do we solve it? I just change this solution to square that. Make sense? Anyone give me review one more time? One more time, I have solved x squared minus x greater than 2. And the solution is I can change this to y squared minus y greater than 2. This is y1. Right? So now I want to solve something squared minus something greater than 2. What's the solution? I just replace this x with x. So answer is very simple. As long as you cast this into this form, as long as you cast this into this form, the answer is out. You just say replace x in the first part by x squared. You will get x squared smaller than minus 1 or x squared greater than 2. Then you solve normally. Now by doing that, you are using the hence method, means you are using the first one. Any review of time? Yes. Yeah, but you must write this line first of all. You cannot assume that just because you want to show that you are using the first part, so must show this line. Later on, then you reject the solution. Later on, then you say this one has no solution. But you must at least write this line. Follow? Alright? Then you say this one, no real solution. Okay? Then you solve this one. I think you all know how to solve this by now. I want to emphasize, okay, the tempting thing some students like to do is, oh, x is greater than plus minus 2. Because you think it's square root. No one. You bring this minus 2 over x squared minus 2 and draw your normal thing and we're done. Okay? So I want to emphasize x minus square root 2 why can't this one? X squared greater than 2, then x greater than plus minus 2. Why can't? Sorry? Yeah. Why cannot? I let you think first, okay? Next week I answer again. Think first, okay? Why cannot? Wrong, why cannot? Okay? Okay, thank you. We'll finish the last part. And next week we'll do APGP. Cannot. Okay, next you think about it. Next week we discuss, okay? Thanks.